Hello friends. Welcome to another video. Today I am going to create a Python program that will solve n-queens problem using backtracking. What is n-queen problem? The problem of placing n chess queens on an n by n chessboard, so that no two queens attack each other. For example, this is a solution for the 4-queen problem. In this solution no queens can attack each other. Let's solve this problem using Python. First import libraries. Pygame. Random. sys. Initialize Pygame. Then creating constants. Width. Height. Next grid size. This is the number of queens. Square size. Divide width with grid size to get square size. Initializing screen with width and height. Initializing clock. This clock is used to control frame per second. Creating game loop. This is the main method of this program. Program logic is controlled from this loop. In each frame program will check for events using pygame.event. If we press quit button program will close using sys.exit. Next filling screen with white color. And call Pygame display update method. Next calling game loop and testing the program. It's working. Next creating a function to draw chessboard on the screen. Creating 2 for loop with range grid size to create n by n board. If row plus column modulus 2 is 0. Set color equal white. Else black. Then draw it on screen using pygame.draw method. Calling drawBoard function inside game loop. Oh, I made a mistake. I forget to add color variable inside PygameDraw.rect. Now OK. Next creating a list queens. This list is for storing queens coordinates. Next creating a function to draw queens on the screen. Giving queens list as parameter. Takes coordinates of every queen. And display it as a circle. Giving gold color to the queen. Now calling drawQueen function inside game loop. Yes, it's working. Deleting the coordinate given for testing. I want to add first queen from mouse input. For that, check for mouse button clicks. If mouse button pressed, store mouse coordinates in two variable. These coordinates are given according to our program's screen size. That is 600 by 600. Divide it with square size to get actual board coordinates. And append it to queen's list. Now queens will create wherever we press on screen. I want only one queen from mouse input. Other queens will automatically add by the program. I am creating a Boolean variable with true value. And takes mouse input only if that first click variable is true. After creating first queen, I will make it false. Next, creating a function named isSafe. It take box coordinate as input and check is that box safe from queens. If safe, it returns true. Else false. I will show how we are going to checking safe. Adding a queen at position 3-2. Those boxes with red numbers are positions that can be attacked by the queen in 3-2. How to identify these coordinates? Queen can attack boxes in same column. Every y value of same column will be same. Queen can attack boxes in same row. Every x value of same row will be same. Queen can attack diagonal boxes. For first diagonal, every box's x minus y will be same. For second diagonal, grid size minus x minus y will be same. We are using grid size 8. So 8 minus x minus y will be same. We using this pattern to identify safe boxes. First, take coordinate of each queen and check for these conditions. If queen can attack the given coordinate, return false. If xy does not satisfy these conditions, it means xy is safe. So we can return true. Next, creating a function named SafeBoard. It iterates every boxes and check every box is safe or not. And it returns a list that contain every safe coordinates. Our functions are working. We got all safe coordinates. Now creating a function to add new queens into queens list. Passing queens list and safe list as parameters. It appends a random coordinate inside safe list to queens list. The program will call this function after the Boolean variable first click become false. We are using clock.tick to control frame per seconds. Now game loop iterates only 2 times per second. So we can watch how program adding new queens. After all boxes become unsafe, program stops adding queens. So we need to use backtracking to solve our problem. Creating some global variables for backtracking. Each time we call backtrack function, backtrack count will increase. If backtrack count is greater than pop count into grid size, it means programs using same patterns continuously. So we increments pop count and reset backtrack count. Then we delete last queen's pop count times. Then store last deleted queen's details in variable deleted queen. And call add queen function. Inside add queen function, if safe list is empty and queens list size is less than grid size, that means we need to add more queens. So we call backtrack function. We need to apply small change in safe board function. Don't show last deleted queen's position as safe. It will repeat same pattern. I didn't got the output because I typed backtrack instead of backtrack count. Yes, we got a successful output. Change frame rate to get output faster. Let's try with different number of queens. Check my GitHub repository in the description for code. Thank you for watching.